Hello, calculus fans. I'm going to give you a field. It has components 3y squared plus 4x cubed and 6xy. Let's evaluate a line integral through this field. The curve C will be the positively oriented portion of the circle of radius 3 centered at the origin. And let's say that the angle that we're going to take along this curve will go from 0 to 3 pi over 4. Now this problem is going to be a lot easier to do if the field is conservative. Let's hope. Let's hope that the field is conservative. And I think from now on, I'm going to start doing that. I'm going to start hoping that the fields that I want to compute line integrals through are conservative. Now, it won't always be the case. Hope is a good thing, maybe the best of things, and no good thing ever dies. So let's let P be the first component, 3y squared plus 4x cubed, and Q is the second component, 6xy. Now, if we compute the appropriate partial derivatives, dp by dy and dq by dx, they're both 6y. Woohoo! That's a good thing. Notice also that the field is defined everywhere. That's a simply connected domain. And so, according to our theorem, the field that we started with is conservative. Great. That means we can apply the fundamental theorem for line integrals. Here's a picture of the curve that we're interested in. And so notice that it's positively oriented. You see that noted here. That gives you the direction of the curve that you're going counterclockwise. So with circles, positively oriented means counterclockwise. We're going from 0, and that's going to be down here, theta equals 0, up to theta equals 3 pi over 4. And so from that, we can get the coordinates of the starting point and the ending point. So 3, 0 is going to be the start, and negative 3 root 2 over 2, negative 3 root 2 over 2 will be the end. Because the field is conservative, we don't need to worry about writing down a parameterization of this curve. All we need to do is find a potential function, plug in the end and the start, and subtract. All right, so the starting point of the curve is 3, 0. The end is negative root 3 over 2, negative root 3 over 2. So all we need to do to evaluate this line integral is to plug in the end point and the start point into a potential function. So little f is going to be a potential function for the field. It's not really all that difficult to see that 3xy squared plus x to the fourth is a potential function. All we need to do is take the gradient of this function, and we should end up with this. Now we can go ahead and evaluate the integral. So all we need to do is plug into that function that we just came up with. And if you work all this out, you'll end up with this number here. Doesn't really matter what the number is. The whole point is that we never had to write down a parameterization. We never even actually had to compute a calculus 2 type integral. We just had to plug in the end point and the beginning point into the potential function that we came up with. That means our calculation is going to be a lot easier than doing it with the computational formula that we've talked about before. Okay, that's all for now.